Hi everyone, it's Miss Frankie. I'm going to be talking about lesson 2.1, which is called multiplication comparisons. In this lesson, we are going to learn about how to actually make a bar model. It's going to be their introduction to them, and we're going to be utilizing them for the rest of the chapter. So in this lesson, one of the things we are doing is comparing multiplication statements. So for example, this says 4 times as many as 7 is 28. So one of the things we have to first do is to actually know what they're talking about. So we know we have 3 numbers here, 4, 7, and 28. Those are going to be in a math problem somewhere. So I'm going to write them exactly as they appear in exactly the same order. Then I'm going to look and see some keywords. I see the word times. Well, times to me can't be in anything else but multiplication. So 4 times 7, then I have this word right here, is. Is a special word because in multiplication problems and really anything else, this word is used to represent the equal sign. So I'm going to put my equal sign in there. 4 times 7 is 28. That's the exact same thing that's written up here that says 4 times as many as 7 is 28. Now when we're using a bar model, what we're going to be doing is actually figuring out what that means. So 4 times as many as 7. So if I draw a little box here, and I know that that's 7. Well, 4 times that same amount is going to be 28. Well, if I think about it, there's 7 plus 7, which is 14, plus 7 more is 21, plus 7 again is 28. So, gotta be able to write that up there. 4 sevens is 28. So we're going to be using a model that looks something like this, a comparison model. There's not going to be anything else to it besides just what's in the math problem. And again, the multiplication problem that is listed here is 4 times 7 equals 28. So looking at another problem, this one stumped a couple of the kids when we were working on it, is that the problem was written backwards, is what they kept telling me. So I was writing down, we had 16, 8, and 2, because I wrote the numbers down in the order that they appeared in the problem. Well, then I remembered, is means equal, and then times, it's multiplication. Well, this is not a backwards math problem. It's just written the opposite direction. It's not anything different than what they've been doing. It's the same as this math problem, 4 times 7 is 28. I can rewrite that as 28 is 7 times 4. I'm still going to get the same answer. So on this problem, 16 is 8 times 2. That's the same thing as saying 2 times 8 is 16. There's nothing wrong with it. It's just another way to write it. And since we're getting older, we're learning to write different ways. So using this as a bar model, if I work backwards like this problem is written here, I'm going to have, I know that there's something that equals 16, and there's something that is 8 times as many as 2. So I have 2 in this box, and then I'm going to have 8 different problems, 8 different little squares here. See if I can get them all under there. So there's 2, 4, 6, 8, 10, 12, 14, 16. So 8 times, right there, 8 times as many as 2 is 16. Now, this comes up sometimes like this, where we have to fill in the blanks. And again, I told the kids just follow it the order it's written in. So, 3 times as many as 6 is 18. So, 3 times as many as 6 is 18. So, the same thing here. 42 is 6 times as many as 7. 42 is 6 times as many as 7. So after practicing this, we got into some word problems. Woohoo! And these word problems use the exact same skill. It says there are 2 times as many kids in band as there is in chorus. There are 5 kids in chorus. How many kids are in band? Well, this is still the same skill, only we're now having to figure something out. This question here, how many kids are in band? So it says there are 2 times as many kids in band as there is in chorus. So I'm going to list, I have band and I have chorus. Well, if I look closely, it says there's 2 times as many kids in band. So that means band's going to have more. So there's band. Band has 2 times. So there's 1 box, 2 boxes right there. And then chorus has to have a box as well. Well, we know from the problem that there's 5 children in chorus. Well, if this represents 5 is then 2 times with band, that means it's the same number that goes in each box. Because we're comparing these numbers, each of the squares represent the same amount. So if there's 5 kids in chorus, 2 times that 5, so 2 5s, is going to tell me how many children there are in band. So in band, there are, and I would count it up to see how many there are in band, there are 10 kids. Finally, we're going to look at a problem that requires the students to kind of fill it in, but work a little backwards on it. So this problem says Scott is 40 years old. This is 5 times as old as his son Junior. Junior is how old? So we're going to still use a bar model that includes our names of Scott and Junior. This time we know how old Scott is. We know that he's 40 years old. So altogether, Scott's going to be 40. And then also, because I got that right there, the problem says that this is 5 times as old as his son Junior. So that means that Scott has 5 squares and his son has 1, because that would show that that's 5 times how old Junior is. So 5 more in there. So I represented the squares with the letter N because I'm not sure how old Junior is, but I know how old Scott is. So now this is a division problem. I'm going to ask, it could be a division or multiplication, but I know that Scott is 5 times as old. So I could say 5 times some number, which in this case I put N, equals 40. Now this is a division problem because I'm saying 40 divided by 5, or I'm saying 5 times N. So 5 times what is 40? Well, looking through my multiplication facts, 5 times 8 is 40. So then Junior must be 8 years old. So I can check that. If I put an 8 into each of these, I can check to see if 1, 2, 3, 4, 5 8s equals 40. There's 16, 24, 32, 40. 5 times 8 is 40. So the question asked me how old is Junior, and Junior is 8 years old. All right, if you have any questions on 2.1, don't hesitate to let me know. Thanks. Have a great night.